Well, welcome to the panel on climate. I'm Bill Schlesinger, Dean of the Nicholas School. I think you all will share with me the opinion that this has been an absolutely delightful day of delightful talks and discussions. And this panel will not let you down either, addressing the problem that faces every nation of the world and certainly has been vexing for the political bodies that govern our country, the question of climate change, global warming, what to do about it, and who should do the doing. We have a distinguished panel of commentors today. I want to introduce everybody quickly, and then we'll have their initial thoughts. Right to my left here, Thomas Crowley, the Nicholas Professor of Earth System Science in the Nicholas School, Earth and Ocean Sciences Division, widely known for his work on paleoclimate and how the past can be used to help model the future. To his left, Marty Hoffert, who I now see says Professor Emeritus at New York University. That must be new. The last time I met you, you were still Professor. 2 weeks. Still Professor of Physics at New York University, has written widely on the question of what our options are for energy if we are going to address the climate issue seriously. To his left, Fred Krupp, President of Environmental Defense at the national level in the New York office, a longtime veteran of many environmental advocacy battles from one of the groups that has been so influential in spurring environmental policy here. And at the far end of the table, Jonathan Wiener, the Perkins Professor of Law in the Law School and a Professor of Environmental Policy in the Nicholas School, the kind of joint appointment that the President and the Provost are so proud of in terms of how Duke University functions, and which, from my perspective as Dean of the Nicholas School, certainly produces the rich environment that allows us to reach out to other schools on the campus. Now, when our panel had a little bit of email and telephone conversation to think about how we wanted to approach the issue of global warming, exactly what would be the best way to talk about this. And I think we certainly wanted to start off with some thoughts about what is the problem, which I will ask Tom Crowley to address in particular. What are some barriers to making progress, both barriers that have been barriers in the past and what are barriers right now? And finally, and in particular, I think the usefulness of today and this launch or summit event, what can the Institute here at Duke do to help? Certainly we want to help Tim Perfetta set his agenda and a plan for how we can have the maximum impact here. So Tom, let me begin with you with some thoughts on exactly where we are. What is the problem with climate change right now?
Thanks, Bill. I'd like to thank everyone for the opportunity to speak here. I'd like to thank Peter Nicholas for the job. And I have a two-page statement here. I left copies of it up above here on one of the shelves there if you're interested. Just wanted to put my thoughts together on it. I don't have any figures. And I'm just going to summarize science very briefly because I think there's less and less reason to dispute the scientific conclusions now, so there's not as much reason to spend a lot of time on it. Within the last 5 to 10 years, it's become increasingly clear that the Earth is warming and that human-induced greenhouse gas increases are responsible for the rise. In some places, we are already experiencing a magnitude of warming that we have not observed in several thousand years. In the Northwest Territory of Alaska, robins have been observed. Northwest Territories of Canada. Robins have been observed. The Inuit natives of that region have lived there for approximately 10,000 years and do not even have a word for robins. So this is like a unique experience to them. Now, global warming is here, whether we like it or not. There's been a huge sea change in the profession in the last 5 to 10 years with respect to acceptance of that. We have uncertainties with respect to how much the climate temperatures are going to warm. There's there's less and less dispute about the fact that it's actually here already. And one of the scary things about it is that we've only used about 5% of the fossil fuel reservoir, and yet we're already seeing clear signs of it. In addition to generally rising temperatures and sea level, we expect, and sometimes already observe, significant melting of glaciers, increased precipitation in northern mid-latitudes, and there are reasonable possibilities of increased drought in many parts of the tropics in the U.S. central interior, more severe winter storms in some places, and possible changes in the strength of tropical cyclones. I wanted to bring this up because the connection between hurricane strength and global warming is still legitimately debated among different people in the climate community, where you don't have people entering with different agendas in mind, okay? It's just, as you go to a finer and finer scale, sometimes it becomes harder and harder to predict with confidence the behavior of some systems. And although it would not surprise me at all if tropical cyclone activity did increase and strengthen, I don't think we can make a consensus statement on that yet. Now, we have enough capability to increase, enough fossil fuel reservoir, known fossil fuel, to increase the global temperatures 5 to 10 degrees centigrade, which would raise the average planet of the Earth to temperatures that have not occurred for about 50 million years. And the temperature change would increase at a rate much greater than anything that has occurred in our knowledge of the record. My experiences and in summarizing the history of the Earth's past climate, and I know of no situation where a warming of that magnitude has proceeded that quickly in Earth history. And I have written about this in peer-reviewed papers. The first one was published about 15 years ago, and I've never had that statement disputed. I've rarely had it quoted either, but I just don't think people like to think about that. But I thought about it a lot and got a lot of feedback before I wrote that paper, and it's never been disputed. So I think with respect to the actuality of global warming, that we shouldn't probably have to spend a lot of time, although, of course, if you have questions, I'll be glad to answer them in the question and answer period. I have a few comments based mainly on observations and some experience in the federal government, which I'd like to add, but of course I have to underline and emphasize that I'm not a policy specialist, so these are just observations, and it's based on encounters of statements people have made in the past that I think can be rebutted rather easily. There are some people who seem to think that everything is going to somehow work out in the end, that cries of the sky is falling have been made before, and somehow it wasn't nearly as bad as we thought it was going to be. Well, my response to those people is that things don't always work out for the best, and we know that from the 20th century history. Okay, we don't have to. It's taking a giant risk to assume that things are somehow going to work out okay with respect to global warming, and that warming will not be as severe as we think it will. With respect to solutions, we have all kinds of ideas of how we can change society in the next 30 to 50 years with solutions on policy and whatever. And the one comment that I would like to make with that is that we so far have not even been able to provide clean water to the world's population, even though we know how to do it at a cost substantially less than it would cost us for reducing greenhouse gases. So I think we have to be rather humble before we go about making predictions and ideas about how we're going to change the world in the future, because I think there's a very reasonable likelihood that we may not be able to do that. And I think it's also important to think that the future we're talking about now, a baseline for a matter of concern among climate modelers is when the CO2 level of the atmosphere will double, because we think that if it gets much above that level, and it could conceivably go to a factor of 7 above that level, we would get increasingly worried that we're going farther and farther out into this unknown territory where things that we can't predict will happen. And we're talking about things that might happen in 40 years or so, but I think it's important to recall that we have known about the energy crisis for 30 years and basically done nothing. So the idea that we're actually going to be able to do something is, we're almost halfway into that lifespan of knowing about the energy crisis, and we're still basically twiddling our thumbs. If there's any hope of doing something, I believe we have to look at the near future with some especially hard-headed realism. Not talk of economists of being a few months or years. I'm thinking of the 5 to 20-year time frame. And in particular, we simply cannot be guided by dogma of either the right or the left. I think we have to try to take as clear and honest a look at this problem as we can. Marty Hoffert has some great ideas of what we might be able to look at farther into the future, but we're having to start now. But I think that we also have to pay attention to what I call the near future and contemplate what we may think of as transitional solutions to eventually an economy and an energy base that is much more energy conserving. And in this respect, I have come rather surprisingly to the conclusion that we have to look at sources of energy such as coal as almost the inevitable source of energy that we have to turn to in the midterm as like an alternate source of energy, but with the proviso being that we put a great deal of effort into making this coal not just the regular coal-fired powered plants of the past, but making it clean coal, okay? Removing the pollution, products such as mercury and sulfur before it goes into the atmosphere, and it's even theoretically capable of removing carbon dioxide. We have a great source of coal in the United States, so there are some economic advantages of doing that. It's not just altruism. And that brings me to another point about trying to talk to policymakers. I don't think that we always have to think about it in terms of doing something for the future and some altruistic gesture that will not be realized in any terms of short-term benefits. Because I'm really rather surprised that people have not approached congressmen in terms of just the immediate or near immediate benefit that can be gained by, for example, improving the technologies of clean coal. We have coal in this country. If we mine it and get the material out of it, we can certainly provide, at least in the intermediate term, a source of energy for the nation rather than buying oil from regions that are very politically unstable and basically providing money to nations that actually support terrorism. So I think there's all kinds of sound reasons not having anything to do with global warming in turning to coal and clean coal as a near to mid-term solution that has, in terms of economic and security and jobs and new technologies, things that would attract congressional leaders on both sides of the fence. I think it's something that it's one of these ways of maybe breaking down some of these barriers. I'm not saying that would be the only thing that we should think about, but I think it's important to come up with certain gestures that enable one to build trust between the different sides that is often not there at present. And finally, I'd like to add that 2 points, I guess. The one being that I fully endorse what Marty is saying about the future, and Marty, I think, will probably say something about the fact that this cannot be done by the private sector alone, and it cannot be done by just reprogramming monies within the federal base budget, which is what many agency leaders seem to think you have to do now. I heard a ridiculous statement yesterday or the day before by the administrator of NASA saying that we can go to the moon without increasing our budget, just doing reprogramming. And they said it would cost $8 to $10 billion a year, and NASA's budget's about $16 billion a year. So they're going to reprogram half of their budget for going to the moon, which is, it's just a bald-faced lie as far as I can tell. You know, you're just not going to be able to do it. You know, you'd be lucky you get up top of the atmosphere. So it requires a real commitment in cold cash by the federal government in order to become a reality. I'm repeating something that Marty gave a very fervent presentation on about 2 or 3 years ago here at the Nicholas School. And the final thing I'd like to make a comment on is that I was here at the meeting last year and on energy, and I was really encouraged by the number of business leaders, prominent business leaders who are genuinely interested in this problem. And I would like to think, and these people may already be doing things like this, I would like to think that, I think in some respects these people have a lot more clout with Congress than academicians. And if they realize that it's not a case of black or white in terms of just, starry-eyed environmentalists trying to change the world, but they're hard-nosed successful businessmen who are really concerned about this problem, I think it's going to be another one of those gestures that will help maybe lower the barriers, at least, in the very unfortunate situation that exists today in Washington in terms of political polarization. Thank you.
Thanks, Tom. Now,
okay, let me...
Oh, I was going to say, now, Tom, of course, has mentioned Marty several times, so I think it's appropriate we move to Marty. And Marty Hoffert, take it away.
Right. Let me, I'll try as much as possible to efficiently not repeat many of the points that Tom made, which I wholeheartedly concur with. Tom is actually a colleague of mine. I'll just briefly say that I've spent about the last 30 years working on the climate problem and the carbon cycle problem, and probably for about the last decade intensively on the problem of alternate energy systems, since most of the greenhouse that we are already experiencing and will experience, and it could be as much as a temperature, a climatic change that we haven't seen since the mid-Cretaceous, when the poles were deglaciated and dinosaurs roamed the South Pole and crocodiles at the North Pole. We have that potential. Frankly, that scared the hell out of me. And as someone with a background in engineering, my PhD is actually in aerospace engineering, I became very interested in the technological side of it, and have for about 10 years been working with colleagues, both in the climate community and in the energy community, on what alternatives do we really have, and on certain key questions that continually come up, and trying to get objective answers, like, does the technology exist today to solve the problem if we just had the technical will? Are the costs a modest increase over what we are paying now for energy? And if we could just internalize the external costs of climate change, can we get there? And some of the answers that we found have not been conventional wisdom. I have limited time, so let me cut to the chase. There are two problems here that are interrelated, and there's a policy, a potential policy solution that I'm going to propose, and I'll try mightily to get to it before my time is over. As far as a behavioral problem, I think that is a separate problem. We are, after all, a bunch of naked apes, only recently emerged from our hunter-gatherer heritage of several millions of years, probably, and may even have imprinted in us behavioral patterns that make it very difficult for us to plan for future serious problems. We have to understand this problem cognitively and act on it, and that's a separate, very important problem. Put it away, put it on the side for a second. The other problem is the objective technological problem, which I'd like to state as follows. Can we continue to run our civilization, our technological civilization, for the next 100 years? I would like it, of course, to extend far beyond that philosophically, where we're growing economically at about 3% a year, inflation adjusted. I'm talking about the world right now. And at the same time that that's going on, for the first 50 years into the century, keep our emissions of carbon dioxide constant, and near the latter part of the century, eventually phase them out. I have some graphics that illustrate this, but I don't have enough time to show it. This is a Herculean job. One way to look at it is that 50 years from now, we're going, and this would be roughly equivalent to keeping the global warming below 2 degrees based on our best estimates of climate sensitivity, that the world will not warm more than 2 degrees. Bear in mind that in the last glacial maximum, we think the Earth was 3 to 5 degrees colder than it is right now. So this is almost as much, and that's pretty much unavoidable. That would correspond to doubling CO2. How much of our energy would have to come from non-CO2 emitting sources in order for that to happen. And I won't confuse you with nomenclature like terawatts. I'll just say that roughly 100 to 300% of all the energy that the world consumes right now would have to come from sources that do not emit CO2 into the atmosphere 50 years from now in order to satisfy those two conditions: continued global economic growth at 3% a year and stabilization of emissions. Beyond the year 2050, in the second part of the 21st century, I'm reminded of a term, I think, by Louis XIV, après-moi les déluges, literally the problems that are up ahead and the way we've been thinking about it would become literally enormous in the second part of the century. But let's just stick to this problem of getting 100 to 300% of the world's energy from some source that doesn't emit CO2. That's of the energy that we use right now. Compare this with nuclear power. The first nuclear reactor, Fermi's nuclear reactor at the University of Chicago, that's farther in time behind us. It was around the 1944 period. And yet, our primary energy is less than 5% from nuclear power right now. We're talking about 20 to 60 times more energy. Now, one could say, why are you emphasizing the supply side? Amory Lovins has this great article in Scientific American last month that we can do it all with efficiency improvements. This is already factoring in a very aggressive improvement in energy efficiency, actually energy intensity, the ratio of energy to GDP of 1% a year for the rest of the century. I'm talking about what we would need in terms of supply to match that GDP requirement. It is a Herculean task, so Herculean that many of my colleagues say, and we've written papers about this in Science and Nature, and they say, you know, I don't really disagree with your numbers, the math is right, but you shouldn't say it. Particularly some of my European colleagues sent me emails saying we've had enough trouble convincing our government to sign on to the Kyoto Protocol. What you're talking about is so much beyond Kyoto, which it is, that it will seem like it's an impossible task and it will lead to paralysis. And as a matter of fact, that is an important issue. You have, on the one hand, people not even believing that it's a serious problem, and on the other hand, the fact that the problem is so difficult, but not, in my opinion, impossible. We looked for models for what might be policy alternatives, and I'm going to propose that a model would be something like the Manhattan Project or the Apollo program, Manhattan Project of World War II, or the Apollo program during the Cold War, where in a relatively short period of time, technologies were developed. I mean, after all, in World War II, we went from biplanes to jet planes in about 7 years. In the Apollo program, we landed a man, I should say a human being now, gender and specific, on the moon in less than a decade, as Kennedy said. And I think it's important to remember in his speech when he announced the Apollo program, which I believe was at Rice University, he said, why do we go to the moon? And this is a paraphrase. We don't go to the moon and do the other things because they are easy. We do them because they are hard, and because accomplishing them will harness the best of our energies and abilities. It's very hard for me to even imagine a politician taking that position right now, but I think it is something that has to be done, and I would like to see a political movement oriented in that direction. I'm really running out of time, but let me quickly say what I think we need to do. This was actually a policy recommendation. The National Commission on Energy Policy, before they issued their report, it was a prior meeting with the Pew Climate Foundation, and I was chair of a subcommittee on renewable energy, and we came up with a specific policy goal, which unfortunately never made it to the National Commission on Energy's report, but this is what we said. We thought that by 2050, we should have the objective of that 100 to 300% of our current energy, which is 10 to 30 terawatts, as we physicists or engineers would put it, of primary energy, should come roughly 1/3 from renewable sources. Bear in mind that renewable sources together collectively, solar, wind, solar thermal photovoltaics, excluding hydro and biomass burning, is less than 1% of our energy mix right now. 1/3 should come from renewable energy. 1/3 should come from some form of nuclear power and that form will have effectively addressed the issues of weapons proliferation and waste disposal. And the third would be from what Tom had suggested, coal, but basically coal in which the coal, instead of being burned in conventional power plants where it's 30% efficiency with the CO2 up the stack, the coal would be gasified, and this would be integrated, what are called integrated combined cycle plants, which involve gas turbines and steam turbines, and a lot of interesting technology you guys may not want to know the details of. But the bottom line is that what you produce is hydrogen and CO2. The CO2 is captured, is put into pipelines, and is somehow sequestered underground, probably in deep saline aquifers. This is the premier technology being pushed by the Bush administration, and I suspect it's because of the importance of the coal industry. Each one of those is potentially important, and each of these has enormous technical challenges, and to me as an engineer is extremely interesting. In the renewable energy field, for example, I believe that we really ought to be thinking about the storage and the transmission of the energy because it's very intermittent and low in power density. And I'm personally interested in a technology called solar power satellites, where sunlight could be collected in Earth orbit and geostationary orbit and beamed to the Earth. And if this was done with lasers, it could actually supplement PV arrays, photovoltaic arrays, which after all only produce electricity in the daytime or when there aren't any clouds. Again, there isn't enough time to talk about the advantages and hurdles of all of these. But if we developed as a political objective that we, the United States, would initiate a very broad gauge Apollo program to study alternate sources of energy, the first step of which would be to change the mission of the Department of Energy, which you might think is to develop new sources of energy, but that's not its official mission. Its official mission is toxic waste disposal and stockpile stewardship, which means making sure that the nuclear weapons that we're not allowed to test actually work if we ever had to use them. We have a lot of assets. We also have a lot of problems. There aren't enough students in this country studying science and engineering. I was unfortunate, I hope I'm wrong about this, but I did not see very many people from the engineering community participating in this very important workshop. I think this community needs to get input from people with physics and engineering and physical science backgrounds who really understand the objective issues of developing alternative energy sources. I just came back from the panel on energy, and everything those guys said, I completely agree with. These are tough-minded guys from industry, and their message is basically the same as mine, except for this initiative, which I would love to see developed at the Nichols School, to develop research and development programs specifically focused on making revolutionary changes in the world's energy system that will enable our high technology civilization to continue without at the same time introducing catastrophic changes in climate and other environmentally unacceptable impacts. Again, not enough time to elaborate. I probably talked enough. Thank you.
Thanks, Marty. Let's see, we got to jump all the way down the table here for a minute because Jonathan was the second person that we asked to talk about barriers to some of our progress.
Okay.
And so, Jonathan, let me turn this over to you. Jonathan Wiener.
Yes, thank you. I don't know if they're going to. Great, thank you. I am really delighted to be here. I seem to be talking too loudly. and am extremely excited about the Nicholas Institute for Environmental Policy Solutions launch. It's something that I and other colleagues have been working on for quite a while here, and we are extremely grateful to Pete and Ginny Nicholas and to President Broadhead, Provost Lang, and Dean Schlesinger for giving us the support to make this a very successful initiative, and to Tim Profeta for joining us to lead the endeavor. I am this year on much appreciated sabbatical leave, spending the year with climate change policy experts in Paris. And so for my title of this session, I thought of Samuel Beckett's famous play En attendant Godot, Waiting for Godot. And of course, the problem with Godot is he never arrives. And similarly, the concern, the barriers that Bill Schlesinger just mentioned, may suggest that we may be en attendant Kyoto. And what I want to talk about are not the technological barriers, but the institutional barriers to accomplishing successful solutions to climate change policy, and how the Nicholas Institute for Environmental Policy Solutions might contribute significant headway in this arena. Here is an estimate made a few years ago by Jay Edmonds of the effect of the Kyoto Protocol on global emissions and concentrations. And although it's very difficult for you to see the small numbers here, the point is that the line without the Kyoto Protocol and the line with the Kyoto Protocol are extremely close together. And this graph assumes that the Kyoto Protocol includes the United States, which it currently does not, and that there is no leakage, a point I'll talk about in just a moment, and that the Kyoto Protocol extends with its targets imposed for the rest of the century, whereas in fact the Kyoto Protocol's emissions limits extend only to approximately the year 2012. So this is a very optimistic and yet troubling picture of what the Kyoto Protocol would accomplish, which is hardly any reduction in greenhouse gas emissions. Now, the reason for that is partly the target that is set in the Kyoto Protocol, but in some ways, I think the more fundamental reason is the lack of participation in the emissions limit obligations of the Kyoto Protocol by the countries whose emissions are growing most rapidly. And that, I think, is the major challenge, to find a way to engage those countries. So in an effort to try to reconstruct climate policy, Dick Stewart and I wrote this book, which addresses key challenges for climate policy solutions. The coverage, Mr. Oborn, spoke last night about full economy-wide coverage and covering multiple greenhouse gases, all sectors of the economy, and sinks. In the forestry session a moment ago, Stuart Pym gave a pitch for covering sinks in a climate change regime that is to provide an incentive for forest conservation. Second major issue is participation of major emitting countries. The third is the instrument choice question. That's, for example, cap and trade versus taxes or something else. And the question of what targets to set. And those choices have to be based on some criteria, including how much they would protect the environment, what they would cost, what their incentives for innovation, dynamic improvement would be, and fairness. Let me say just quickly about the coverage issue. There are strong reasons to have any climate change policy solution cover all the major greenhouse gases, not only carbon dioxide, but also methane and nitrous oxide and a number of other gases. Those other gases are more potent per unit than carbon dioxide, and omitting them from a climate change regime could invite perverse cross-gas shifts. That is, if a climate change regime only covered carbon dioxide emissions from the energy sector, then in full compliance, industry, entirely well-meaning, could shift from activities that emit carbon dioxide to activities that emit other greenhouse gases. And so comprehensive coverage of methane and other greenhouse gases as well as CO2 has major environmental advantages. And this graph simply shows that the switch from coal to natural gas would reduce CO2 emissions, but in countries where natural gas systems are allow a lot of fugitive emissions, that it could actually increase global warming contributions on net because of the methane that leaks from natural gas systems. That's not a significant problem in the United States, but it has been in the past in some other countries. And comprehensive coverage reduces costs significantly. This is just a summary of 4 studies in the 1990s suggesting that covering more than CO2, covering methane and sinks, would reduce costs by 30 to 90% compared to a CO2-only strategy. Now, the upshot of reducing costs is not only that that's good for the regulated entities, but that reducing costs encourages action. It encourages participation. Put it this way, the more a climate policy regime costs, the less countries will adopt it. The less it costs, the more they will adopt it. So cost effectiveness is crucial to environmental success. And the Framework Convention on Climate Change and the Kyoto Protocol both took this strongly comprehensive approach covering all sectors, gases, and sinks as well, important incentive for biodiversity conservation. But unfortunately, the current European Union emissions trading system is CO2 only. The Regional Greenhouse Gas Initiative, RGGI, being prepared in the northeastern U.S., has some mechanisms for including some of the other gases in offset programs, but is basically focused on CO2 emissions. I hope it has an option to expand, and one would hope that that would be undertaken. The second issue is participation, and here's the key reason that the Kyoto Protocol would even with U.S. participation, achieve so little, is that the countries obligated to limit their emissions and reduce their emissions by about 5% over the next few years through 2012 under the Kyoto Protocol are the countries whose emissions are not growing very fast. And the countries whose emissions are growing extremely rapidly are not governed by emissions limitations. Now, of course, there's a real fairness question there of whether major developing countries should be required to limit their emissions now when the highly industrialized, wealthy countries had no limits on their emissions in the past and were able to grow in part with that freedom. And so, as I'll argue in a moment, there needs to be some way to not coerce or cajole, but persuade and invite major developing countries to reduce their emissions on terms that are favorable to them, on terms that are acceptable and persuasive to them. Action at the local level, at the state level, at even a national level by one country on its own faces a number of downsides. As Mr. Oborn argued last night, state-by-state action can produce a patchwork of different rules that are very costly and cumbersome to comply with. Moreover, if, say, the United States or the European Union acts by itself, or even the Kyoto Protocol parties, it omits control of emissions growth in unconstrained countries. But the even more serious problem is the problem of what's called leakage. That is, that if emissions are regulated in one place, then emissions-intensive activities will shift to unregulated places. And that would undermine the environmental effectiveness of the regime. It would raise costs compared to a more global regime. But even if that concern is overstated, the political fear of leakage is a strong inhibition on action by first movers. And you can see that concern playing out now in the northeastern U.S. states, and clearly in the Senate resolution adopted in 1997, 95-0, that the United States would not adopt a climate change treaty that didn't include meaningful participation by developing countries. There are additional downsides: higher abatement costs, market power exercised by the fewer permit sellers, and there may be legal constraints on local action by U.S. states under the Dormant Commerce Clause or under the Interstate Compacts Clause. So there's a whole variety of problems here. But the problem of engaging other countries is a very serious and difficult one. Most countries in the world would view themselves as both emitters of greenhouse gases and potential victims of global warming. They would bear costs of global warming or benefit from its prevention. But there are some countries at the far right in this picture who are essentially only victims, like small island states, who are strong advocates for emissions control, but it's relatively unimportant whether they themselves control their emissions, which are small or trivial. The real difficulty is the left side here, the yellow outer edge, countries which are sources of emissions who would bear the costs of emissions control but don't view themselves as beneficiaries of emissions control. potentially because they think that global warming would be neutral for them or even beneficial. And those countries will not only want to be free riders, letting other countries bear the cost, but they might actually oppose emissions limits. And there's some reason to think that Russia and China both view themselves as in this category, that they would think that global warming might lengthen growing seasons and increase agricultural yields. You can see statements like that from the official state climatologists of Russia and China over the last 10 years. And that they would rather not only themselves reduce emissions at their own cost, but also not have major emissions reduction activities by other countries. And here's an estimate by Richard Toll. This is highly speculative. Richard Toll, T-O-L, a German researcher, trying to estimate the winners and losers from climate change. And the thing that really stands out here is the line labeled CPA, the upper line that sticks out to the right in the upper graph, which suggests that centrally planned Asia, that is China, would enjoy benefits from global warming over the next 200 years. Now, there are costs in the near term. But even if this is wrong, and Toll was trying to make the best synthesis estimate of all the impacts of global warming that he could, the perception that this might be true could substantially affect negotiating position by China, Russia, others. So we have to find some way of engaging those developing countries, and this interacts strongly with the question of instrument choice. And I won't go through all the details and options here, but the key question between cap and trade, a tradable emissions permit system, as adopted in the Kyoto Protocol, the EU emissions trading system, and proposed in the McCain-Lieberman Act, on the one hand, and emissions taxes, as mentioned by Mr. Oborn last night, is a crucial question and relates not only to cost effectiveness, but to this question of participation. Clearly, either of these would reduce costs dramatically. Here, this is a study from the early 1990s, and we've known this for quite a while, that allowing emissions trading or using emissions taxes would cut costs roughly in half. The particularly interesting point here is not only that global costs would be cut by half from 3.5% to 1.5% of GDP, and meanwhile generating substantial benefits, as Jared Diamond mentioned at the lunch talk, but that if you look at the China column, China would go from a net loser under a no trading regime to a net winner just from the trading system, not including here, this chart does not include the benefits of preventing global warming, which, as I mentioned, for China might offset this number. But a 5.8% increase in household real income forecast by this model for China as a result of selling emissions permits. So that, I would argue, is the most plausible, most attractive means of engaging a country like China in an international regime to reduce emissions, is the opportunity for China to be allocated headroom allowances and then sell those allowances back to wealthier countries. Trading versus taxes, economists have shown very elegantly, can be identical if we know what the costs are. They diverge if we are uncertain about costs. Depending on the relative slopes of the marginal cost and marginal benefit curves, one might prefer one or the other, whether we're more concerned about cost escalation or damages escalation. But the point about engaging participation has not been addressed in those economic models, and that is the crucial issue here. Taxes alone don't have a mechanism for attracting participation by key players unless they're combined with some kind of government cash transfers, government aid transfers, using the tax revenues to make lump sum transfers. And yet those lump sum transfers themselves would tend to undermine the incentive effect of the tax. Moreover, there's this problem of fiscal cushioning, that countries would play games with their internal tax systems. If we had international emissions taxes, they would reduce other taxes so that the net effect on their actual emissions was diminished or negated, and yet they would seem to be in compliance with the greenhouse gas tax. Whereas that problem does not exist for a cap and trade program, because the cap would still constrain emissions even if they attempted to play games to cushion their own industries. So the last point is, how do we make side payments? One option is cash payments, international foreign aid, in effect, to countries like China, India, Brazil, to persuade them to participate. I think this is politically unlikely, but even if it were possible, and something called the Clean Development Mechanism in the Kyoto Protocol is a version of this because it does not require targets or caps to be adopted by countries that accept CDM payments. It has a significant problem of perverse incentives, that subsidies for abatement might reduce emissions at each recipient of the subsidy, but because they reduce the cost of doing business in the subsidized industry, they attract capital inflows to that industry, expand the aggregate size of the industry, and may actually increase net emissions. Secondly, they may induce domestic leakage because there's no cap within each country. Third, if countries know that they can sell CDM credits at, say, $6 a ton, $10 a ton, and a cap-and-trade program would only raise that price slightly, the opportunity to sell CDM credits now with no cap would be at odds with the incentive to join a formal cap-and-trade system. So there's a real dynamic incentive problem there. And there's the normal problems of government aid programs being distorted by political deals, log rolling and distribution. The cap-and-trade program has other problems, but the device of using cap-and-trade with headroom allowances, just as we did in the 1990 Clean Air Act to persuade sulfur emissions-intensive states to join the trading program, and as is done in the Kyoto Protocol to engage Russia, could be done for additional countries, China, India, et al. It's decentralized. It creates a competitive market with strong incentives for innovation, strong role for the private sector, not government aid, but private sector trade, and it avoids those perverse incentives. Now, beyond these kinds of climate change program incentives, side payments, there could also be other side payments, linkage to other issues, such as entry into the World Trade Organization, which is one of the key things Russia has wanted, and the public health co-benefits of reducing emissions, as Tom Crowley mentioned a moment ago. And I think another is appealing to China's role as a great power in the next century or the next millennium. And what does it take to be a great power? One might appeal also to the United States' role as a great power, and what does it take to be a great power? So how can the Nicholas Institute help to find solutions? Provide quality information for decision makers, the key point that Bill Riley and others have made throughout, on the science, on the social science, on policy, and law. I think a second really important task, which has not yet been undertaken, is to link the models of regional abatement costs, what it would cost the United States, what it would cost China, what it would cost Europe, and regional impacts or benefits, the climate change impacts models of what will be the effects of global climate change on US, China, Europe, etc., to the country's negotiating stances. Third, develop creative strategies for side payments to engage participation by major emitters. And I've tried to suggest what I think this headroom allowances approach might be, but there could be other creative approaches for side payments, and maybe some intangible side payments like self-perception as a great power, which ought to be pursued. Fourth, with this patchwork that's already emerging, a plurilateral regime of multiple different policies, the Kyoto Protocol parties, the US RGGI program, the California program, maybe other programs in other places, there's a strong need to advise, improve, and connect those different regional policies. For example, the US Northeastern RGGI program says that it wants to link to the European emissions trading system. Well, there are some significant issues in the details of making that work, and I think the Nicholas Institute could play a significant role. And last, link the issues that Marty Hoffert talked about, new technology innovation, to diffusion. If we develop new technology, we still need demand. There still needs to be diffusion. And so those two have to go together. Thank you.
Fred, perhaps you can give us the final word here, briefly, on what the Nicholas Institute can do to help.
I think I want to propose a tradable time allocation system.
I'll pay you.
My route to wealth. What should the Nicholas Institute do is what I've been asked to answer. And I think what the Nicholas Institute should do, in my opinion, needs to be related to what needs to happen in the world to get things done. So let me give you a few quick thoughts on that. And I think Jonathan is exactly right. This is an international problem. We don't solve climate change without all the countries of the world agreeing to limit their emissions. So we absolutely have to get China to come into a system. So many of the things that we use in our daily lives and buy are being produced in China. How could we even think about solving this problem without getting them involved? But when I think about getting China involved, it brings me back to the United States, because I don't see any way that the EU and the nations that have already signed up for the Kyoto Protocol, the industrialized nations other than Australia and the United States, I don't think they're going to take a second commitment period beyond 2012 unless the U.S. takes a good faith step. So in order for these other countries that have already proceeded without us, and in order for China to agree to do anything, we need to do something here. And this happens to be where the Nicholas Institute is, and so that's a good thing. So what do we need to do here? Well, one thing, I think we need to make the existing systems that are going ahead work. So those states and those regions that have agreed to reduce greenhouse gases and that are adopting systems to do that need to work, such as the RGGI states. All the Northeast United States is proceeding today, next week, with announcing a system related to reducing CO2 only in the utility sector. I think the Nicholas Institute, if those governments make the decision to go ahead, the Nicholas Institute could help figure out what the rules should be so that it really works. I think the country has a big stake in that, and future progress has a big stake in making sure that works. At the international level, the EU has started an emissions trading system in January of this year. Perhaps the Nicholas Institute could have a role in making sure that works. The Kyoto nations are moving forward starting in 2008 for the period 2008 to 2012. On an international level, there may be a role for the Nicholas Institute to make sure that works. In the United States, there's been a lot of talk today about coal, and we are going to burn coal in this country. We're going to burn a lot of it. We're going to burn a lot of coal around the world. So I think we have to face that fact, and I think there could well be a role for the Nicholas Institute to figure out how do we burn coal that is truly clean, so not just cleaning up the sulfur and the nitrogen, which need to be cleaned up, but also to capture, sequester the carbon dioxide, to get the incentives right, to get the government policies right, so that there is a future for coal, and that farmers and those who own forests are given incentives to capture the CO2, that to the extent we can develop ways to mechanically capture it right at the plants, that happens, and all the other dirty things about coal are cleaned up. I think there could well be a role for the Nicholas Institute there. But if I'm right that the world only moves forward on the truly global agreement that we need, if the United States catches up with the rest of the world, the other industrialized nations, then surely we in the United States need a national cap on emissions or national limits or some program to reduce our emissions. And I would hope that the Nicholas Institute, with its combination of representatives and relationships with businesses and environmental groups and scientists and government people, can help to develop good policy that will get us beyond stalemate to an actual program. And that is, critically important, because we sit at the pivot point of history. If the United States doesn't go forward, then I'll have to resign myself to Tom's opening statement that all stories don't always end up happily. And it would be tragic if on our watch this one doesn't end up well. I think we need hope, and we need plans, and that's why there's a few specific things we can work on, and the Nicholas Institute can help make the things that need to happen, which will give us the hope we all need to engage. Education is my last point, Bill. I would say that given the presentation we heard on polling, it's clear that we need more education for the general public, but also for the 10 or 15 million people in this country that really matter to our elected leaders in a special way, and getting to those influentials as well as the general public, I think, is something the Nicholas Institute could help do. So in all those ways, I think the Nicholas Institute could play a huge role in a nonpartisan way, in a science-based way, intersecting with the things that it's pretty clear need to happen at the state level, at the national level, the international level, providing a future for coal. The Nicholas Institute could play a major role at making things happen.
Thank you. Any panelist that ends by saying that further education is needed obviously has the vote of the dean of the school. I have 10,000 candle power blasting me in the face, so it's hard to see hands, but why don't we take a couple of questions and then we will have to break. But there's one there.
In your wildest dreams, from a policy point of view, would you ever see, if we signed on to this treaty or other treaties in the future, some inability of landowners to sell timber, or some trade-off, or some cap, or some forgiveness if there's some big forest fire that releases CO2 that can't be balanced then by carbon sequestration? I mean, is there any impact down on the micro level?
Let me take a stab at that a little bit, because I've been working with Fred on a book on how landowners could tackle carbon sequestration. How do you validate it? How would you get it audited? What would you do if there was a catastrophe? There might even be an insurance industry to make sure that if you sequestered carbon, that in fact your insurance company would pay you if that forest burned down and the carbon was released. I think there is, this will not be a simple set of procedures to work out. Validating the distribution of carbon across the landscape in the face of landscape variability and land use variability, and trying to estimate the carbon stored or lost from a landscape above and beyond what might happen by natural processes, I think will be extremely difficult. Frankly, I worry that we could spend as much effort doing that as the carbon is actually worth. I don't know where this will go, but it is what has led me to be much more in favor of looking at emissions limits than trying to soak up, essentially trying to collect the marbles that have spilled out of the bag. What?
Can I take
Yeah, Fred.
I think the problem with climate change is so huge that we need to do everything we can. So I absolutely agree with Bill. We need to crank down on emissions every way we can. But for landowners, and the United States is rich with a huge land base, who have the opportunity to be part of the solution and soak up carbon to the extent that it's scientifically verified, absolutely, I want to let them play and let them be part of the solution. Last week I was in Kansas with a group of landowners that own 5,000 acres apiece. Together they owned 1 million acres. And they have the potential to change their current practices and go to a no-till practice, which Kansas University is currently estimating, and it all have to be verified. If they leave all the corn on the soil, in a year, each acre would sequester another 3/4 of a ton of carbon. So 3/4 of a ton times 1 million, 3/4 of a million tons in a year just from the farmers I was visiting with. It's not going to be the whole problem, but it's the reductions we need, as Jonathan's graph showed, are so enormous. Let's let everybody who can in a scientifically verified way play. Let's let them all play. Let's unleash all the ingenuity we have by having a system of incentives. That's the American way.
I'm getting the sign that we must finish, and that's an upbeat note on which to finish. So let me thank the panelists, and hopefully you will join me in thanking them as well.